Alright, today we're talking about section 11-3, which is on the surface area of pyramids and cones. So we'll start with a little vocabulary, as usual, and then we'll get into a couple of examples. So, vocabulary. A pyramid is a polyhedron where one face can be any polygon, and all of the other faces are triangles. So I have two examples of pyramids here where I have one face here at the bottom, which is a pentagon, and the rest of the faces, or the walls, are each triangles. And on this one I have one face at the bottom here, which is a hexagon, and then each of my other faces, again, are all triangles. So those are pyramids. Now the base is that one face, if you will. It's the one face that I'm referring to right there, which is the one that can be any polygon. Okay, so that's the base. The lateral faces are basically all of the triangles. So the lateral faces are referring to all of the triangles or all of the walls of that pyramid. Okay, so that's kind of the little vocabulary there, just so you can identify what I'm talking about when I say lateral faces and base. So, the two more things you need to know here. There's what is called the altitude, which is the segment from the vertex to the base that is perpendicular. So the vertex is the top here. It's this top point. All right, so from that vertex to the base, so I'm going to draw a line down here. It's going to go right to the base, and it's going to be at 90 degrees. That is the altitude. The slant height is something very different. It's just the height of my slanted pieces, or the height of my lateral faces, or the height of my triangles. So here I have a lateral face. I have this triangle is a lateral face there, right? If I'm going from the vertex to the base, along that slant though, it's still going to meet at 90 degrees, right? It's still perpendicular, but it's slanted. That blue line there is called your slant height. So it's just the altitude of one of the triangles, where the actual altitude is the height of the actual pyramid. Okay, so that's the difference between the two things. Now, we are going to find the surface area of a pyramid, and to do that, we need to first look at the net. So I have a couple pictures here. I'm dealing first with this rectangular pyramid, which again just means the base is a rectangle. The net of that, if you leave the base in the center, which I think is the easiest way to do it, if you leave the base in the center and then just like basically cut the pyramid at that point right there and slice all the edges, it would unfold like so, where each triangle would then just be laying on the outside there. Okay, so it would unfold like that, which gives us the shape that I just drew. Okay, so that's the net. Now if I wanted to find the area of that, well, first of all, I just have the area of the base. No big deal, right? The area of the base is just the rectangle or the square or whatever it is, which is just length times width. That's not a problem. But I need to then find the area of each of these triangles, and to find the area of a triangle, I need to know the base, right, and the height. So let's call this side length so that we don't get confused with the other use of base before. So let's say this is the side length, right here. And this is the height, but it's the height of what? It's the height of one of my lateral faces, which we just said is called the slant height. So what we call that is L. So L stands for slant height. So then the area of that triangle, right, the area of this one triangle is what? It's just 1/2 the base of that triangle, which is the side length, times L. Well, how many of those triangles do I have? I have 1, 2, 3, 4, right? I have 4 of those triangles, and I'm assuming this is a square. I don't know if I mentioned that before. I have 4 of those triangles, which means the area, or my lateral area, would be what? Well, 4 times the 1/2 SL, right? 4 times the 1/2 SL. Which then leads us to what? Well, we can just move some things around here. which I want to do, I'm going to use the commutative property to say 1/2 and then 4s times L. And the reason I'm doing that, so I just use the commutative property, I'm still multiplying the same thing. 4s is just what? It's just the perimeter of that base. So I can say that this is again 1/2 P L, where P stands for the perimeter of the base and L stands for the slant height. So I'm going to summarize that here. The lateral area is 1/2 PL, where again P is the perimeter and L is the slant height. So if you know the perimeter of your base and you know the slant height, you can find the surface area, or the lateral area at least, right? You can at least find the lateral area. To find the surface area, it's the same thing. You have your lateral area, plus we can't forget about the actual base itself, right? The surface area is including the actual base itself, so it's B plus LA for your surface area. So I can ask both questions. I could say find the lateral area or find the surface area, which means just add the base to it. So it's the same concept with the pentagon. Again, slant height here, side length there. 5 side lengths is your perimeter times 1/2 that. You end up with 1/2 PL. So any pyramid, you're going to get the same thing. So that was really quick. If you want to go into more detail there, feel free to do all of this work there. But I'm going to move on. I just wanted to show you the picture because it's a pretty star, so why not? Anyway, so that's how you find it. Now let's look at it. Oh, not an example yet. Actually, I'm going to skip to the example. So, I put them in the wrong order. If I wanted to find the lateral area it's asking for and the surface area. So first, the lateral area. Again, the lateral area is just 1/2 PL. So what is the perimeter of our base? So first of all, I have P is, or one side length is 7. I'm assuming it's regular, which most of them are going to be that you're going to see. So the other side lengths are also 7, which would give us a perimeter of 35. It's a pentagon, right? So 1/2 of 35. Now we don't know the slant height yet, so we need to use the fact that this here, if I drew the slant height in, it would look like so. Slanted up the wall here, just like that. That forms a right triangle. I know one of the side lengths is 8. I know one of the side lengths is 6, which means 3, 4, 5 triangle. This slant height is 10. And if you wanted to use Pythagorean theorem there, feel free. For the sake of the video, I'm using 3, 4, 5 because it's faster. So my slant height is 10. Now how I would multiply these, I would multiply the 1/2 and the 10 first because 10 is even. So 1/2 times 10 is 5. So I end up with 5 times 35, which is 175, hopefully. We don't have the units, so we'll put, I can't spell, look at that, units squared. Now the surface area, we just have the lateral area, so this is just the lateral area plus the base. So we need to know the area of the base. Well, if you notice, this segment here is just the apothem, right? That's 6. And we know that one of the side lengths here is 7. So it's a regular polygon with an apothem of 6 and a side length of 7. And the area of that is just 1/2 AP, right? This is a review, the apothem times the perimeter. So the apothem times the perimeter, we have 1/2 times 42, which is 21. Then I would add those together. I have 21 plus 175, which I'll write over here. The surface area is 196 units squared. So as you can tell, you're going to have to go back and review if you need. That was a terrible box. You're going to have to go back and review the area of regular polygons using the apothem to help you find that. Okay, so there's a couple things here you need to remember. Don't use the 8 for L. Pardon me. Alright, I totally lost where I was, but I'm thinking I was saying that a lot of students will call this their slant height because That's the one given, which is terrible thinking. That's the altitude, not the slant height. Okay? Anyway, let's talk about a cone. So a cone is pretty much just like a pyramid, except it's not. It has a circular base. So it's, same concept. So we have our base here. We have a base there. We have a base three-dimensional here, right? Base is at the bottom there. The base is a circle. Your lateral face is just one big face that goes around the edge. Okay? That's not, you don't have multiple faces. It's just one continual piece. Okay? So, one thing that a lot of students have trouble with is picturing the net. And even when I tell you that this is the net, a lot of you don't believe me. So what I encourage you to do is get like a birthday cone as pictured here, right? A birthday hat cone thing, and cut it and open it up and see what it looks like. It should have this shape here. Now, again, this picture can be a little off because a lot of you may think that this is a 90-degree angle, okay? Which it's not necessarily, or we at least haven't shown that, so be careful there. But that's not a huge thing. So that's what the net looks like. It's harder to show you that the lateral area is still 1/2 PL, but it is. Again, where L means the slant height here. So this is L. It's the slant height. But it's true. Just trust me, I guess I could say. I could show you at a later date, but for the sake of this video, it's not drastically important for now. So I'm not going to go there yet. But the important thing is this. It's still 1/2 PL, so it's just like the pyramid, except now the perimeter of my base, well, what's my base? It's a circle, so it's the same thing as 1/2 of the circumference of my base times the slant height, or in other words, 1/2 of 2 pi r, right? The circumference is 2 pi r times L, which these cancel. 1/2 times 2 is just 1. I'm just left with pi r L. So if you're the kind of person who just wants to memorize something for each thing, that's fine. Memorize pi r L. If you don't, and you just want to stick with this and you'll get to pi r L, that's fine too. It's up to you. Okay, so they both have 1/2 PL. It simplifies to pi r L in this case. And the base of a cone is just a circle. So really this is just pi r squared, right? That's the base there. It's pi r squared plus the lateral area pi r L. So pi r squared plus pi r L. Let's do an example. If I tell you that the diameter of this cone is 10 and the altitude is 12, I want you to find the lateral area and the surface area. So the lateral area is just pi r L, which is what? Well, we know, do we know any of these things? The radius is 1/2 of 10, so the radius is here, which would be what? 5, so I have pi times 5. The slant height, again, same concept as the pyramid. I need to make a right triangle to find L. L is here, it's not 12. So 5, 12, you should know that L is 13. That's why I use Pythagorean triples. If you didn't know that off the top of your head, then do Pythagorean theorem, and you'll get square root of 169, which is 13. And 5 times 13 is 65, so this would just be 65 pi units squared. The surface area is just the base plus the lateral area, which again is pi r squared, or 25 pi, plus 65 pi, as we just solved for, which is 90 pi units squared. Okay? So that's kind of the mechanics of it. It's pretty straightforward. The only thing that can be tricky is solving for L on the cone and using the apothem and possibly the radius, etc., going back to regular polygons on a pyramid. Those are the only really tricky parts. Helpful thought, you should never get a lateral area that's bigger than the surface area, right? The surface area should always be bigger, so if they ever have multiple choice where it says the surface area is smaller, automatically cross it off, because that's impossible. So, fun fact of the day. Other than that, that's it. I'll see you guys later. Thanks for watching. Bye, guys.